this video, we're going to continue our discussion of variables that we started in the previous video, looking at the different types of information we might record about cars. But we're going to look at some terminology that's typically associated with variables in statistics. So, we can have different types of variables. And generally speaking, the main kind of distinction between different types of variables is we want to distinguish between quantitative and qualitative. When you see the word quantitative, you might notice that it kind of has the word quantity, essentially, or the prefix quant, hiding inside of it. Quantitative data is typically, well, it's always numeric. So quantitative data must be numeric. But there's one additional criterion that needs to be satisfied in order for a piece of data to be construed as quantitative. It's not enough for it to just be numeric. It must also must be able to have meaningful mathematical operations performed upon it. Okay, so to give you an example of something that at first seems like it might be quantitative, but is not in fact quantitative, is your zip code. Right? If I collected zip codes from everybody in our stats class, they would definitely be numeric. But if I try to do meaningful mathematical operations with zip code, I could find total zip code for people in the class, and I could find average zip code, but they wouldn't actually be meaningful. It doesn't mean anything to talk about average zip code. As a matter of fact, it likely wouldn't even be a valid zip code. We'd probably get some sort of decimal value at the end, and zip codes don't have decimals. So it's not enough to just be numeric. You have to be able to perform some kind of meaningful mathematical operations on that variable, such as adding, averaging, those kinds of things. Okay, that's what makes variables quantitative. Any variables that are not quantitative by definition are called qualitative, or some books call them categorical. Those terms can be used interchangeably. So qualitative or categorical data is data that is not quantitative. Okay, so it can either be not numeric. So if you're dealing with something like color information, if we're talking about Skittles or something and we want to record the color of the Skittles, color would be qualitative because it's not numeric. Also, things like zip code that are numeric but can't have meaningful mathematics performed upon them, they would also count as qualitative or categorical data. Okay, but if a piece of data is numeric and we can perform meaningful mathematics upon it, then it is a quantitative piece of data, okay, or a quantitative variable. So if we go back to our list here that we were looking at with the market research for the car company, and we look at the kinds of variables that we collected here, we can talk about which variables now are likely qualitative and which are quantitative. And what you might notice when you look at some of these too is depending on how the data were recorded, that actually can make a difference, right? If price here, if we're assuming it's in dollars, we could find the average price for cars, we could find the total price for a fleet of cars, and they would likely be numeric measurements. So that would make this a quantitative variable. Color is going to be qualitative, right? Because color is not numeric, and we certainly can't do any meaningful mathematics on something that's not numeric. So color is a qualitative variable. Make and model, those are both qualitative as well. Here, the year, even though year can be construed as quantitative, most likely this would be used in a qualitative sense because it is numeric, the year of the vehicle. You know, this is a 1997 Ford Escort, this is a 2012 Chevy Malibu or whatever. But it's not as though we could find a total year that would be in some way meaningful, or average year that would, well, average year might be meaningful, but here this would probably be used more in a qualitative sense rather than quantitative. Engine type and transmission would also both be qualitative because they're not numeric. And here size would depend on how it was measured. If we actually measured the size as, say, the length of the vehicle in feet or in inches, you know, from bumper to bumper, that could be quantitative because we could find average length and we could find total length for a number of cars, that kind of thing. If, on the other hand, size is measured in like subcompact, compact, mid-size, you know, crossover, SUV, that kind of thing, then that would be a qualitative piece of data. So here, this would really depend on how it was measured. Could be qualitative, could be quantitative. It just depends on exactly what you mean by size. But that's the idea between the difference between qualitative and quantitative data. Other important pieces of information to know about data, in addition to the type of data that you're working with, qualitative versus quantitative, is where did the data come from? Are you dealing with population data or are you dealing with sample data? When we're dealing with population data, the data are collected from every individual of interest. By contrast, sample data, the data are collected from only some individuals of interest. Or in other words, a subset of the population. Now, in general, when we're engaging in the practice of statistics, it is very rare to be working with population data. And I think you can probably tell why. If you're talking about a large population, like if we're doing a voter survey to see, for example, how many people approve of the president and the job that the president is doing right now, that's a really large population. And for the most part, polling agencies and statistical agencies don't have the time and they don't have the money, they don't have the resources to actually poll every registered voter in the United States. Okay, so we likely wouldn't use population data. And usually population data is pretty hard to come by unless your population is very small. You know, if I was interested in our population as being just the students within our classroom, it would be really easy for us to get population data. But if we're talking about a really large population with a lot of individuals, we don't end up working with this very much. Usually statisticians end up working with sample data a lot more commonly, where you are taking a smaller subset of the larger population and assuming that you have sampled using a valid sampling method, which we'll talk about in a later video, then your sample acts just like a miniature population, so that data that you collect from the sample should, in important respects, be fairly similar to data from the population, and you can use the sample data to estimate the population data. Okay, so usually we'll be working with sample data. Now, another key thing to know about population data versus sample data. If you collect data from the entire population, so let's say I did collect that approval rating from all of the registered voters in the United States, and we computed a value from that, like let's say the population proportion of registered voters who approve of the job that the president is doing, that value that we compute from population data is called a parameter. So values computed from the population are parameters. By contrast, if we're talking about sampled data, and instead of looking at all registered voters in the United States, maybe I select a random sample from just Whatcom County, and I want to know, what's the approval rating likely to be in Whatcom County, but I don't pull all Whatcom County voters, I only pull a small sample of them. And then I compute that proportion who approve. So I've computed a value from the sample. That would be called a statistic. Values computed from the sample are statistics. Now, the other really important thing to know about this, aside from the terms parameters and statistics, which the book introduces now, but it will continue to refer back to these terms throughout the rest of the quarter, is that parameters are fixed. Once you have defined a population, that population has one and only one parameter associated with it. So again, to give you an example, let's say I polled everyone in our class, and our statistics class was the entire population that we wanted to work with, and I wanted to compute the average age for our class. Well, there is one and only one average age for that population. That is a fixed value. By contrast, if I drew a sample from our class, let's say I just drew 5 people's names out of a hat, and I computed the average age for just those 5 people, that would be called a statistic, because I wasn't dealing with the whole population, I wasn't dealing with the whole class, I was just dealing with the sample. And if I were to draw another different sample of 5 people, that sample wouldn't necessarily have the same average age as the first sample. So parameters, because we're dealing with the entire population, those are fixed. There is one and only one population parameter. Statistics, however, vary from sample to sample. It is not necessarily the case that each sample from the same population will have the same statistic. It is possible for multiple samples to have the same statistic, but generally speaking, statistics will vary from sample to sample.